All right. So good news is we are covering two new concepts today. However, they are very, very, very similar to each other and they're very easy. So we're doing area of a sector and arc length. Now, what do you think a sector is? Sector of a circle. It's like a slice of the circle. Yeah, if you're thinking about a piece of pizza, a sector would be if you're thinking about a whole pizza, a sector would be a piece of the pizza. Now, arc length, what do you think is different about this arc length versus the arc lengths we were learning about last class?
Because it's based off the center.
Yes. So last class, you could only use those on what type of circle? Unit circle. So now we're going to be finding the arc length on circles that are not the unit circle, okay? So let's go ahead and do which one first? Arc length. Yes, arc length. So arc length is a portion of the edge of a circle. And all that you have to do, whenever you look at a problem, it says find the arc length, and it gives you a radius. All you have to do is set up a proportion. Now, what makes this a proportion?
They're set equal to each other.
Yes, two what are set equal to each other?
Fractions.
Fractions or, starts with an R? Ratios, good. Now, how do you create a ratio always? What do you do? What over what? What goes over what in a ratio? You think the bigger one goes over the smaller one? Ah, yes. The part goes over the whole. We did this way, way back in probability, right? When we were doing geometric probability, we put the part over the whole. Now, our first ratio is going to be our lengths. It's our length ratio. And the second one is our angles. We need to compare two things about the circle. So we know that we're solving for the arc length here. So is that going to be my part or my whole, do you think? Arc length. Does that seem like a whole to you or a part? It's a part. Good. Now, how would you find the whole arc length on a circle?
360.
So that is the whole angle. And in a circle, the whole angle is always 360. Ah, yes, I heard it a couple times. When we're finding the whole length around a circle, that is called your circumference, right? How do we find circumference? Yes, 2 pi r squared. No. that's area and circumference put together. It's just 2 pi r. Or, yeah. 2 pi r. And the angles, this part is the angle that creates the arc. Angle that creates the arc. I wish there was a simpler way to write that.
Angle of arc.
Angle of arc. Angle of arc, maybe? No.
Is there a symbol for arc?
No.
Why isn't there a symbol for arc? There's a symbol for literally everything, but there's not arc.
Yeah, this means it's arc AB. But there isn't just like, oh, that means arc. I don't know. All right. So now let's try it. Let's go ahead and try it. Find the arc length. I know on mine it's a little blurry. Is that a 5 centimeters, tell me?
Yeah.
Yes. All right. So what are we solving for here? And where does that go in our proportion? Ah, yes, it's our part of the length. That's what we're solving for, the arc length. What is the whole arc length? 2 pi r. And what is our r? And then what is the angle that creates the arc? 24. And what is the whole angle on a circle? Beautiful. Now, how do you think we solve this? Ah, why or how do I know I can cross multiply here? Ah, you have two ratios set equal. Good. Lauren. Now, we cross multiply and we get 360x is equal to, what's 2 times 5?
Thank you so much.
You're welcome. Now, I'm going to tell you guys that you should leave it in terms of pi until the very end. Meaning, do not actually multiply the pi until the very end. Because some of your problems are going to say, leave your answer in terms of pi. So it's easiest just not to deal with pi until the very end. So we have 24 times 10 pi. So we're going to leave it in terms of pi. That means do not multiply the pi. So 24 times 10 is 240. Now what do I do to get my x by itself? Yeah, divide by 360. So someone tell me, what is 240 divided by 360? Whoops, that's not what cancels. Yes. You get 0.666666667, which is another way to say 2/3. So we have 2/3 pi. What's our unit? Centimeters. Or if it doesn't say leave in terms of pi, you can either write it like this, or you can multiply the pi in. So if we multiply the pi in, I believe, I think it's 2.09. Beautiful. I'm that good. I do that math in my head. Not really. I just memorized it. Any questions so far? Does anyone find this crazy difficult? It's pretty straightforward as long as you remember, okay, the whole length is the circumference, okay? Now, sector area is almost the exact same thing. Almost. A sector of a circle, like we were saying before, is a portion of the circle. It's a wedge shape. It's a wedge. An area of a sector is a portion of the area of a circle. Oh, no, sorry. Is the area of a sector of a circle. Oh, bless you. Now, what do you think R stands for? Good. Always the radius. And X, what is X there that I put? The angle. Now, I know this says big A, but I want you to put a big A and then in subscript SEC. So that we can clearly see, oh, this is area of the sector. Area of the sector. All right, so like I was saying before, area of the sector is very similar to arc length, except are we going to have the same hole, do you think? The same hole for our first ratio? Are we going to be using circumference? Oh my gosh, we're going to be using area, right. So we have part over whole still. Our first ratio is no longer going to be lengths, it's going to be area. And our second one remains the angles. So our part of our area is what we're solving for, our area of a sector. What do you think the whole area is? For area of a circle. Pi r squared. And angles is the angle that creates our sector. And our whole angle is what? 360. So what was the only thing that changed, really?
It's area.
It's area instead of circumference. That's the only thing that changed. So, in this problem, we're trying to find area of the sector. Where is that variable going to go? Area of a sector, where's that going to go? In our proportion. It's the part of the area. What is our whole area? Pi 6 squared, good. And what is our angle? Our part angle? And our whole angle? How do I solve this? How do I know I can cross multiply here? You have two ratios set equal to each other. Good. So I have 360 times area of a sector is equal to, what's 6 squared? Good. Now, should I multiply the pi in right now? Probably not. Good. And 30 times 36 is? Good. 1080. What do I do to get area of the sector by itself? Divide by 360. Whoops. So what is 1080 divided by 360? 3. 3 what? Pi. And is there a unit? No, I'm going to create one and say it's 6 inches as our radius. So what's our unit? Inches what? It's area. Squared. Or, what's 3 times pi? 9.4. And do you think you should be typing in 3.14 in your calculator? No, what should you be doing? Hitting the pi button. Good. Now, if it doesn't tell you in terms of pi, which answer should you be giving? It actually doesn't matter. Leave it in either way, either notation. If it does say leave in terms of pi, which one should you use? The pi one, obviously, right? Any questions on any of this? Pretty straightforward, right? All right.